Ladies and gentlemen, like I said, this does not take long. Let's keep it down, please. What is a triangle? A three-sided something? What adds up to 180? The angle's good. Okay. So, real quick, just a quick thing to remind yourselves. A triangle is created by three non-collinear points. Three non-collinear points create a triangle, which gives you three sides. Triangle. Three angles. Convenient. And you're right, the sum of the interior angles is always 180 degrees. We actually utilize that interior angle sum quite a bit later on when we start talking about polynomials, because you're able to figure out how many triangles fit in something, then you'll know how many degrees are in something. For example, that's an octagon, right? It's got eight sides. Inside the octagon, you can fit 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 triangles, which means the sum of the interior angles in an octagon would be 6 times 180. Things like that. So, we'll worry about that later. You are able to, you are able to classify your triangles by sides and angles. Sir. Oh. Just worry about those two. I'm not worried about this right here, okay? You guys have all been able to classify triangles. This is one of the first things you guys learned about geometry back in grade. One of those grades.
Which one?
I don't know. Whichever one you learned it in. But I know you learned it.
It was like
So when you go back and you think about types of triangles, they were classified by either their sides or their angles or some combination of both. So, what is one type of a triangle? So far, that has been the same type that every other class said first. I think it's kind of funny. So, an isosceles. Let me ask you this. An isosceles triangle, when you're talking about an isosceles, is that talking about classifying it via the side lengths or the angles? Side lengths? Because what do you know about what do you know about isosceles besides the name? One of the ones with different sides. What is an isosceles? Let's do that first. Thanks. You can have an isosceles trapezoid too. So there. What is it? The what? Sideways? No. Yes, sir. One side is different than the other, so what you're saying is two of them are the same? So let's do this. An isosceles. An isosceles triangle is a triangle that has exactly one set of congruent sides.
Which one do you want to sort this under?
It doesn't matter. I'm just saying you can do it either way. It looks like that. You have one set of sides that are congruent. Now, the other part of the isosceles, or I was trying to get at there, whether it was with the sides or the angles, is that an isosceles triangle can be classified under both of them. Because what happens here is that you have your two sets of side lengths that are always that are identical to one another. And if you look at your tick marks, notice how this one is pointing at this angle, and this one is pointing at that angle. That means that you wind up with what are called congruent base angles as well. So it has one pair of congruent sides and one pair of congruent angles. So a lot of times you will see an isosceles triangle drawn out two different ways. It'll say something like this. If this, then this, or this, and this. And remember, triangles don't necessarily have to be facing the same direction. You can rotate them all over the place, okay? It makes no difference. Those angles that are congruent in an isosceles triangle are called base angles. And just because they're on the bottom in my diagram doesn't mean they have to be. They can be on the sides, it can be really anywhere, depending on how the triangle is rotated, okay? So it isn't that big of a deal. I know you guys have all seen that, so I'm saying crazy about it. Okay? What's another type of triangle? Equilateral, good. Equilateral triangle is what? An equilateral triangle has all three sides, three congruent sides, and three congruent angles. You'll see that, which means that this will happen. More importantly, if you know that you have three angles that are the same in a triangle, what is each one of them going to measure? 60, good, yeah. All of these guys are going to, each one of those is going to measure 60 degrees. Okay? Because there's 120, or 180 degrees total. If all three of them are the same, you just divide it out by 3 and you get the 60. Okay. So, if all three sides are the same, that means you'll have all three angles the same. And if all three angles are the same, that means you will have all three sides the same. It's equiangular and equilateral. We just normally just call it equilateral. That's all. Okay. What's another one? Yeah. I couldn't hear you. What? Scalene. Good. What is a scalene triangle? Yeah. All three sides different. If all three sides are different, what do you know then about all three angles? They're all going to be different also. Okay? So a scalene triangle has nothing in common. No angles the same, no angles the same, no sides the same. What's that? Scalene triangles, you can, like I said earlier, you can actually mix and match these things together. You can have a scalene right triangle. You can have an isosceles right triangle. Okay? It's completely possible. I'll show you how all this will work here in a second. Oh, speaking of, a right triangle. What makes a right triangle a right triangle? That's even better. I'll give you that one. What makes a right triangle a right triangle? It has a right angle, yeah. Now, just because I'm curious if you know this, if I draw a right triangle, it'll have one right angle. You agree? What's that?
This is the side of the
Well, can't this
It's
one?
not really sideways, but kind of sideways.
But what if we did this though? I mean, can't I just do this?
Yeah, you can.
Can I do this?
That looks like a phone.
I know what you're getting at. I'm just being annoying because that's how I am. So, if you have a right triangle, you'll have a right angle. In a triangle, how many total degrees are there?
180.
So if we take out the 90-degree angle, how many degrees are left? This is your right triangle shirt, boy. What do those two have to add up to equal? What do those two angles have to equal? 90. They have to equal 90.
45 and 45.
Not necessarily.
No, they can be.
Can't it be 89 and 1?
But those have to go they have to be 90, but I like 45.
Now, what you're saying here is what happens when you have what's called an isosceles. An isosceles right triangle. An isosceles right triangle has side lengths that are the same. And you're right, both these two angles then have to be equal. Well, if those two angles have to be equal, they have to add up to 90, which makes them both 45. Okay?
Yeah.
That isosceles right triangle is one of the most important triangles that we look at. It's one of the basics of trigonometry.
Do you want us to write the whole thing?
I'm just saying that you can have what's called an isosceles right triangle. We spend quite a lot of time dealing with the 45, 45, 90, and then we will deal with what's called a 30, 60, 90 triangle here real soon. Those two triangles are what's going to set you up for your Algebra 2 trigonometry, and then if you guys go on to pre-calc, what they do with that as well. The whole thing is based off of two triangles. If you know the ratios of the sides, everything's easy. Okay? If you have a scalene right triangle,
Wait, which one's that one? The other one was isosceles.
if I have a scalene right triangle, it just means that my side lengths are different, but I still have a right angle, like 3, a 4, and a 5. What always holds true for right triangles? Oh yeah, it has a right angle, thank you. But it has to deal with the side lengths. What always held true for right triangles? Starts with the P and ends in the Pythagorean theorem. Very good, it's the Pythagorean theorem. The only thing you have to remember about the Pythagorean theorem, besides what it's called, is that the value of C is always for what we call the hypotenuse. The hypotenuse is the longest side length, and it's always across from the right angle. One thing you guys will start to notice is that the longest side length will always be across from the largest angle. The smallest side length will be across from the shortest angle, and so on. It's one of the things we talk about here pretty soon. I think it's in 4 or 5. I don't know, but you'll see it again soon. So we had mixtures of isosceles, right triangles, scalene right triangles. There are two other types we haven't said about when we look about angles for triangles. We've done the side length ones. What do you got? Yeah, exactly. The last two are just acute and obtuse. An acute triangle or an obtuse triangle. Really, really easy to remember the differences here, or how they're defined out, is that an acute triangle has all 3 acute angles. And then the obtuse triangle would have how many obtuse angles? How many obtuse angles can you have in a triangle? 1. You can only have 1. Because what's an obtuse angle? More than 90. So if I have something that's more than 90, and there's only 180 degrees to go with, I can't have more than 1 obtuse. So as 1, unless we're in a different plane. Okay. So a lot of stuff we're looking at today is working with the interior angles of a triangle, adding up to 180 degrees, finding the missing angle, things like that. There's really not a lot of craziness that we're going to concern ourselves with today. The other thing I want to show you guys is something we talked about last week when we did a proof. Last week we did a proof of what we call the external angle theorem. Remember that? How the outside angle was the same as the inside too? It wouldn't touch. Well, that actually comes up in here today. It's called the exterior angle theorem. And it basically says the following. An exterior angle is an angle on the outside of an object. In this case, we're talking about a triangle. In other instances later on, we talk about polygons. We'll use some variants of this later. But in this case, I'm looking at what's called the exterior angle of a triangle. So, it basically says the following. That outside angle is equal to the two it doesn't touch. The exterior angle is equal to the sum of the two angles it doesn't touch. And it is so much easier to write it out in terms of that kind of word language as opposed to the awful way they write it out in books and stuff. That is much more user-friendly.
Why do they write it like that? Is it like just different things?
No,
I feel like
it's just written. When you write textbooks, they write things in a very technical manner. And when I write stuff out, I try to make it in a manner that you guys would understand. Because I don't like textbook definitions, but if I can reword it so it makes sense, why not use that, right? It's easier, okay? It's easier to think about that way. All right. Now, we talked about this before. We actually did the proof of this last week. I'm not going to bother doing that again. But you're going to be able to do stuff like this. Excuse me. Y is the exterior angle. It's the angle on the outside. So, what does it have to equal? Why don't we have a calculator out? Because we're doing a lot of algebra here. It's much easier to press a button than be wrong. Yes, ma'am. Yeah. The outside angle equals the two it doesn't touch. Has to be 158. I know, but she also said 138 at first, and I said, why don't you get a calculator so we don't screw this up. Now, let me show you again why this works. How many angles are in a triangle? 3 of them. These two are 70 and 88, which gives you obviously 158. Subtract 158 from 180, you get what? 22, I believe? Now, take a look here. 22 and what are supplementary? Oh, yeah. 158. That's how this stuff works. Rules of supplements, that's how it all works. It's just quicker.
Can you go over that again? Just like
What's that?
Go over this again.
Which part?
The whole thing. Yeah. Like where you started, like where you got the 158, so you got an 88 and 70.
This angle is on the outside,
Yeah.
so it's equal to the two angles it doesn't touch.
Yeah.
70 and 88 is 158. That's it. What I did here was saying that if you add those two together, you get 158. Subtract that from 180, you're left with 22.
Okay.
What's the supplement to 22? 158. That's all. I'm just showing why it worked. Exactly why I said make sure you got it covered. Okay. This is salt. You also can do stuff like this. Now, so far today, people are like, oh man, I don't know how to draw that. Ooh. So, guys, please. Okay. If it was isosceles, you would have a bunch of tick marks for either angles or sides. I don't see that, so you can't just assume it, okay?
Well, I don't have my glasses, so everything kind of looks like
Well, why don't you have your glasses?
because they're broken and I need to buy other ones.
So, as we go through stuff like this, yes, sometimes it's not the easiest things to draw. I would suggest, if you are drawing this one out by hand, it is a lot easier than you think. It's a triangle, bring it back, and do that. It's not terrible. When you get big picture problems, it's always easier just to pick one spot and start. There's really only one angle that you have enough information to solve for. Which one is that? One, exactly. Because inside the triangle that has the angle 1, there's 2 other angles. So, what's 45 and 65? Why don't you use the calculator that's on your desk without hurting your brain? Okay, well, it's 110. So, what's left over then for angle 1? 70. 70, 45, and something add up to equal 180. What's the something? How much? 65. 65 and 20 is how much? How much is left over for angle 3 then? That's all it is, guys. These problems are really that simple. It's just a matter of figuring out exactly where you're going to start a problem and work your way out. Okay? There's nothing crazy to this. I know that all of you guys are going to fly right through this. Okay? Let me show you a couple of algebra problems with the exterior angles, and I'll probably just let you guys finish up work. Anyway, exterior angles. Solve for x in both of them, please. The outside angle equals the 2 it doesn't touch. $51 and 3 is how much? 54. Variables on both sides of the equation, just pick on the little guy. So I'm going to move 2x, I'm going to move 8 at the same time. I get 2x, and x is? Now, remember, sometimes I'll ask you to solve for x, sometimes I'll ask you to find an angle measure. If you had to find angle measures here, what would you do? Yeah, substitute back in. So 23 times 2, 46. 46 and 3 is 49. 3 plus 51. So these two are add up to equal 100. So this should equal 100 as well. 4 times 23. So that's what 46 and 46 is 90. No, 92. Yeah, excuse me. 92 and 8 is 100. Yep. Very good. Same deal on the other one. The outside angle equals the sum of the 2 it doesn't touch. Outside angle equals the 2x plus 103 minus x. You have a lot of algebra here tonight, guys. A lot of quick solve for x's here. Combine your like terms. Add the 7, subtract the 1x. We get 5x is 110. And x is 22. Hopefully it's not too bad, right? Yes, I'll see through most of the stuff. Okay. Excuse me. Let me give you guys some problems then. What I want you to do is in the book, and I got to show you guys, remind you guys how to get to the book. It's on page 221. It's section 4.1, page 221. 14 through 36 evens. And to remind you guys of how to find said book. I'll pull it back up in a second. Just remind you guys how to do this. Ladies and gentlemen, I don't want to have to show you this again. Come on. Geometry. Chapter 4. Oh, look what this says. Arrow, arrow, arrow. Here's the tab to open chapters 3 and 4 from the book. Where do you think I'm going to click? Right where that arrow is pointing at. Oop, I moved it. Once it loads. Yeah, remember there'll be a little pop-out tab that'll come up here. You just click on that and it'll open it up, okay? Remember the book itself, when it's PDF'd, is just 2 chapters at a time, so you just have to scroll through, okay? Just click it and it'll pop out. And remember, it's not that page number of the of that. You have to actually look at the book itself, okay? And scroll through. So, let's see, what was it? 221? Just read what it says. And pretty much yes. Ladies and gentlemen, you have time to work. Let's work. I don't want to hear it. Okay? I will pull it up, the first bunch of problems here for you. You guys got this down? It's already all on the calendar as well. I will recommend when you guys get down to the problems where it's 22, 24, and 26, you might have to solve the other angles to be able to get to those angles set up, okay? To find angles 2, 4, and 6, you might have to actually find 1, 3, and 5 as well, just so you know, okay? Problems are up here. You guys got stuff to do. Let's go.
There's someone at the door.